everything fine, we can start. Can we?
Yes, Professor.
I'll free this camera. And I can go there. Yes. Let's see what we have today. Today we have our caption is Fourier transform of periodic signal. Let's start from the idea. As you saw in our previous action, in our previous lecture, everything fine when we operate, let's say, in the space of harmonic signals. And something strange happens when we, let's say, go out of this comfort zone. We also can take a look from another perspective. Our knowledge in the basics of electrotechnics. What we got? We have, let's say, tools, there's a Kirchhoff's law, Ohm law, and so on, for DC networks, or ideal sine or cosine, or ideal network of harmonic signal. And nothing for, let's say, triangular voltage or rectangular voltage, or we saw real current. For such voltage we have nothing. It would be nice to somehow extend our, let's say, tools to the area of non-harmonic signals. Basic idea is to use imaging or change system of coordinates. Let's say we have something in our Cartesian, let's say x, y, z, coordinate system. Our world, something. We don't have range for something. We have range for hexagon, square. So, we can try one trick. We can create space with a special crafted coordinate system. Where this strange object, let's say, nice round object, use special crafted coordinate system. If we have direct transform from the original, it's our world, from normal system to the special crafted. So if this is, let's say, we need a functional transform for it to convert it to our special crafted system, where it is simple to operate and we can perform any operation we desire. But to use results, we need also inverse transform from the ideal world of our crafted system to the reality where we are now. So idea not to try solve problem directly, but transfer problem to the special crafted system or space where we can use some, say, handy tools, solve the problem, and then get a result via inverse transform. The same can be explained in another way. We have, let's say, periodic signal, which here m is an integer and t capital is repetition period. Question, can we replace it with the sum can we replace it, or let's say explain it as a law of some handy time functions? For example, harmonic. It's the same idea, because this, if it is possible, if it's not just can be, but real possible to find such row of some time function, so it will be really equal to our signal, this will mean what we have created a space with coordinate system, let's say F3 and so on. We have created a space where this time function serves as a base of coordinate system. Sounds okay, it sounds attractive, but unclear. First moment, to create a system of coordinates, we need an independence between the function, or you may find it in literature, zero correlation between functions. So if we have system, let's say, from first to, I don't know, function, we need, it's extremely important, and to ensure what integrate in infinite time is 0 for any I from 1 and any G for 1, 2. And of course we need to exclude moment when I will be equal to G. It's called orthogonality. We need to, let's say, third covenant of orthogonality. We need independence between functions forming our coordinate system. Why? If we not fulfill this covenant, our network regime will not be a point or something exact, but space. If any pair of the function is dependent, linear or non-linear, it's not important. This coordinate will be fake. And equation system describing our network regime, it's for network. We need to solve network regimes. So equation system describing this network regime will be underdefined, and solution of underdefined system, not a point, exact voltage or exact current, but a space, somewhere there. Sorry, it will be failure. So we need to fulfill orthogonality covenant. We need an orthogonal system of functions. Problem is, it isn't so easy to find such system. Bad news. Good news. We started from the periodic signal. If we operate, I will repeat, with periodic signal, it's enough for us to solve a network regime to solve one period. It repeats. To solve one period, again, it's enough to let's say, all magic work in the limited time period only within this time limits of orthogonality. One period should fit in this time period. If we can, let's say, from 0 to period, it's okay. We only need to...
Professor, what is Fi and Fj?
Fi and Fj is some elements of our functional system. We have, let's say, we have a box of functions. I will open this box. But the first idea, you can have any function. Take a math book. It's a lot of functions there. But first point, system of the function, some handy function. What's the idea? Key idea. We have something complex, some complex voltage or current for which we don't have tools. Our toolbox is, let's say, basics of electrotechnics gave us instruments for DC and ideal IC circuits. Is it right? Yes. If we can somehow convert our complex voltage or current in a form of, let's say, DC or ideal IC or something easy to integrate, something easy to work with, it would be, well, it will help us. But this handy function, we will, let's say, term image often used. If we image our real voltage, current, and so on in this special crafted world of ideal function, the first key element, functions, what we use to, let's say, craft a system of coordinates, should be independent. So, integrating within orthogonality, our integral, or it's a classic, magic works from the moment when the magic stick hit till 12, till midnight. Yes? It's our time, do what you want, but get results from 0 to the T2. I will explain it. In reality, there are quite a lot of such function systems. But most of them, very few, work in infinite time. Most are usable only in some limited time range. So, we just need, when we operate with the periodic signal, it's okay to ask only this time range when magic works should be longer or equal to one period. Okay, it's one covenant, it's one condition, and we have condition number 2. Condition number 2, we need non-deforming or non-crippling conversion, direct and reverse. Here we have time space, here we have I'll show it later, but in fact it's a space or discrete frequent space, but it will be later. The condition I'm talking about ensures that all this conversion is not crippling, not deforming. It's called the condition of unity base. Should give us 1 for any 1. If we have function system or box with function fulfilling such condition, it will bear a name or mark orthonormal. Any orthogonal system, any system of function where elements are independent, can be converted to orthonormal form using so-called arithmetic multiplier, which is 1 divided by square root square isn't a problem. if you have orthogonal system, no problem to convert it to orthonormal. This condition ensures, officially called in terms of unity base, ensures conversion this way and return. It is very, very nice when we can image our complex signal to the ideal world of orthogonal functions. But until we can get results back to our world, it's useless. Where to start from? Original idea belongs to Jean-Baptiste Fourier.
Professor, I hope you will do an example too.
1 second. Where is my... Oh, it is... sorry, I'm bad. What is T1, T2? Wait a second. I will cut the way. So question is, what is T1 and T2? Am I right?
No, Professor, that's understood. I just wanted to mention that I hope we will do an example of the conversion.
Yes. Not on the example, we will see it live with real signal. But let me finish with the theory. Okay? So, idea of Mr. Fourier was to use ideal harmonic base. Let's take F0 just one divided by square root from the period. In today's term, it will be the DC component. Sine cosine divided by period. The third one should be square root sine double frequency. I can another one here. Square root cosine, and so on and so on and so on. Triple frequency, quadruple frequency, and so on. It's a system of the trigonometric function. This nice square root stands for coefficients to make the system orthonormal, but you can easily check by default the system is orthogonal in the range from 0 to 1 period. I don't know how in your country, in Latvia, each school has a math class, and each math class, it's a math, I don't know why, but every teacher has it. It's called a unity circle. Cosine, sine, and something like this. Every people in Latvia hates this circle. It's so boring to sit on a math class watching this stupid circle. But what we see here, when the radius is 1, when cosine is 1, sine is 0, isn't it? And on the other hand, when sine is 1, cosine is 0. They really form a pair of orthogonal vectors. Pair with the double frequency again formed. Remember Descartes or Cartesian system. So, sine and cosine at multiple frequencies give us a good base to create a coordinate space where to image our signal or decompose our signal on a system of nice harmonic functions. It's all nice, but it's not all. Remember, signal should become a sum, say from 1 to infinity, f t. Function should be orthonormal system. If we have a quite good system, allowing us to make the sum infinitely close to our original signal, we will have full system. Full. But where can we get factors or coefficients? We have, let's say, components. Use sine of single frequency, of double, of triple, use cosine of single, double, triple, and you'll get. But how many? Should I take one part of the sine, or 3, or one, maybe 1/5? At this moment it's unclear. Where to go, where to run, what to do? At first, we need to understand criterion of precision. In general, we have to select set of coefficients or scales, scale factors, to ensure best precision, most precise. But what is precise? Very important key moment. Founder of all this, but is Fourier, selected an Euclid norm or distance as a precision criterion. Euclid norm, square root of, we will have infinite S naught minus the sum infinite of t. It should be square. This will be correct. Yes. It is an Euclid norm. Distance between our signal and its representation in a space, in a functional space. We're creating on a base of orthonormal function system. The best set of coefficients by Fourier idea should minimize Euclid norm. So the closest representation. It's well based because on the other point of view it will minimize the energy of the difference. But we should understand, but it will create a best approximation or closest, but closest in average. What it means? If we have, let's say, spike, energy of the spike, because it's short in time, energy of the spike is negligible, so or relatively small, and the spike will not be counted. Maybe very sharp changes with a huge difference in amplitude, but which in short time, meaning small energy, will not be counted. So, by Fourier idea, the best set of coefficients is one what minimizes to infinite square and assuming in the orthogonality space within one period, it's only one best set of factors, only one, extreme. It can be found using traditional way of mass analysis. We need to solve system 0, system of partial differential equations. Solving such system, we will find extreme corresponding to the closest possible approximation. Don't worry, Fourier did it. The answer will be something like, we can, within a period, Fe twice. Solution is simple. So for trigonometric form, if we use system, something like being square root sine of and being square root cosine if we use such trigonometric function system as a base for our decomposition or base of coordinates in our space, we will image our signal we will have a very, very usable role on our disposal. Wait 1 second. So our signal can be represented as DC component, one DC component, plus sum, well, let's say k will change from 1 to infinity, of ck cosine plus sk sine k by t. Very usable form. Here, ck are cosine factors or coefficient. How many cosine should we take in our mixture? Sk sine coefficient, how many sine? And you can see it's a row of discrete frequencies. K to p divided by period. And one node to free yourself from double coefficients, norm coefficient used to normalize orthogonal system is combined with the A. So here we have both and if we have both 0 to time cosine here is the formula for cosine factors. No problem to get a sine. Again, the same. Sine. Key formulas for us to get a signal representation, any periodic signal. Again, it's important. All this magic works only for periodic signals. With the help of these two integrals, we can extend or represent our signal as a row of harmonic components or harmonic signal. It here was something complex, but determined and periodic. We can explain it or replace it with the set of harmonic signals. One moment. I need to service my black pad. One moment, I'll be back. cosine, sine are orthogonal. We can use theorem of Pythagoras. We can write our signal as again DC component plus some, say, infinite cosine, not enough space. Okay, it will be multiplied by cosine of plus some angle phi k. Ideal AC component. Cosine should not give any problem, it's just because communication guys were first on place, and they, when in power engineering use sine, they started from cosine, so here we have cosine, but it's not principle. This cosine is ideal AC. Current or voltage or what we want. Factors. Harmonic amplitude. Square. Square. Ideal AC components or ideal harmonic component, harmonics. We can decompose any periodic signal into row or set of harmonics. Only one moment for you can find let's say remark or note, it should be signal of limited energy. More precise, there are Dirichlet conditions or convenants. Such decomposition or imaging, it's the same, possible only if exists from the absolute value integral and its first derivative. It would be better to fulfill it in such form. If exist these two integrals, it's a Dirichlet condition. Transformation or Fourier decomposition is possible. This one bit later. Yeah. I would like to show another usable form of the same rule. It was created on the basis of Euler's formula. Euler's formula, let us explain cosine as a sum of a power divided by Euler's formula. If we assume alpha being we can receive Fourier law in a complex form. Signal can be replaced as 1/2 sum from minus infinity to infinity a power k here component with negative number, it looks like a negative frequency. In reality, a conjugate, product of conjugation of the positive number. The idea is what? We have component rotating forward with the speed they will have positive angle. At the same moment, we have component rotating in opposite direction. Real sum of them. If we take a real part of such sum, it will give us double results. So we can rewrite it again as dc plus a real part of the sum changes from 1 to infinity, complex amplitude a power take K1 and you see what? The Heaviside idea from the basic of electrotechnics. Known symbolic method, representation of a AC voltage or current as a vector on a complex plane, this law will reduce to symbolic representation if you take K1, only first member. DC and set of ideal harmonics. How can I get easy? Harmonic coefficients are cosine phi k sine of phi k or your k. Or directly is an integral. Sorry, I need a factor. 2 by time half a double p divided by period easy. I have this one, this nice formula, gives me ability to convert periodic signal to the sum of ideal harmonics on a complex plane. And if I remember, it's 1/2 the sum, infinity to infinity. Yod, K. I have inverse transform or way to return from the ideal space to the real, to the reality. Something unclear, isn't it? Something very extremely unclear. I think we need what we need. We need an example. Am I right? All this appears to be quite unclear.
Yes, Professor.
The idea is what? Periodic. This is periodic signal, repeating each period equals. We have periodic function of time. We can represent it with DC component plus here is vector represented by complex A1, complex coefficient. It rotates, let's take where you have, I will simplify, with the omega equals, it's from basics of electrotechnics, plus this one is represented by A2 and it rotates with double frequency. I will use small yellow one. It's A3 and has a rotation rate of triple omega. Bit clear? No?
Yes, Professor, but which equation? The idea is clear, but what equations do you use exactly?
1 second, you see. In general, to get all this A1, A2, and 3, and so on, where it is, each A is scale of half d by half my signal a power Mhm. 1 second. This one gives us how many at a single frequency, how many at a double, how many, and at which C complex amplitude gives us not only length of vector, but also its, let's say, zero angle. It has a zero angle of phi k. Okay, let's try to decompose something familiar. Other term used if we have A0, A1, infinity, so the to 0, at which we can minimize the error. Term spectrum is used as in optics. If we can present our signal as a rho, term spectrum is used, and such decomposition may be called as spectral analysis. But okay, let's analyze something. I think red will be okay. Let's analyze a red signal. Here we have time, here we have signal, so it's by half, t by half, double by half, and so on. Nice signal. It's equals to t by half time, and here I should have t by half. And minus e. 1 time f plus 1 t by half. Yeah. Is it readable? Oh no. Yeah, readable. Amplitude minus t. Nice rectangles. Can we analyze such signal? Good question. Signal, get ready. We will decompose it.
Professor, in this case, since there is no elements or something, we can directly go into equations.
One second. Yes, we can directly get coefficients. Give me a moment, I'll show how. Let's try to do the magic on rectangular voltage. So we need to find a zero, complex scale factors. How? We have a very nice equation. It can be found as t by half in our signal a power. Nice formula, isn't it? Let's use it. So, in our case, what we will get? Double E divided by first, maybe it will be more aesthetic, from 0 to t by half, a power this is number 1 minus to 0 a power and I'll split one integral in two for that do I have? Negative halfway. This will be 1, and for positive halfway this will be number 2. Now it will be double E divided by period multiplied by 1 E divided by 2, and it should be yep. This way better. And multiplied by F from 0.
Professor, that's I or J? It's I, yeah?
It's imaginary. This one is square root from -1. A power starting from minus half period and to 0. Something like this. I think period and period should go, also 2 and 2 goes. And if my note is right, I will have amplitude divided and P, yes, multiplied by P, starting from 0 and ending at a half period, minus E power K divided by period, and from minus half period to the 0. Something like this. So it's A divided KP multiplied A power of K T by half divided by period minus 1 minus 1 plus A power your K T by half divided by T kp multiplied by 2 minus m kp plus what I'm doing, a power kp. Yeah. GGKP. Do you see the Euler's formula? I see double Euler's formula here. So I'm writing who's calling and why. Wait 1 second. I'll say what I'm busy. Oh. You. Psh. I'm using send to so E divided by your kp, and I have 2 minus 2 cosines of kp. I have applied Euler's formula to this term. So I have divided by your kp.
Professor, isn't it minus 2?
Sorry? And I should have here 1 minus cosine of kp.
The final step, Professor, it's both ik or one is j? Both e powers.
Yeah, it's j, it's square root from -1. Sine of imaginary part. No, this is not needed. I swapped. I swapped the lines.
So in that case, the e values we can just sum up together.
No, not one has a plus sign and another one has a minus. We can sum them together without the Euler's formula. Or we need to use natural logarithm. But it's not profitable in our case. In our case, it's very profitable to get cosine because it will lead us to the time function of cosine. Wait 1 second, I'll show. I can show the answer. So, component number T will have a complex amplitude as double E, double amplitude of our original C, divided by GKP, 1 minus cosine of KP. Let's see what it means for DC component of A0. Cosine of 0 is 1. So it will be 2e divided kp. 1 minus 1 equals to 0. No DC component in this signal. Double frequency. Cosine of is 1. So 1 minus 1 equals to 0. For the quadruple frequency, A4, cosine of 4p is 1. This means what at quadruple frequency we get 0. So for any odd frequency, we get 0. Okay, what's with the A1? Frequency of original signal. P 1. Cosine of P is minus 1.
2 pi over t.
Equals 4e divided your kp yes. The same for the triple frequency. We will have divided 3 1 cosine equals 4e divided by 3 your p, and so on. I can write my rho as a time function. I can replace my signal as 4e divided by p multiplied by cosine of omega p by half plus 1/3 cosine of 3 omega p by half plus 1/5 cosine of 5 omega. White plus minus, and so on, and so on, and so on. Because division by G or J in Latvian means what vector will be rotated by 90 degrees in counter rotation direction. This can be rewritten in more let's say in more compact form, knowing what cosine of something of p by half equals to sine of alpha.
Professor, can you explain how we got 4e over pi again?
Sorry? How we get what? Wait 1 second. I'll switch on my microphone to diminish this delay. What should I explain?
4e over pi, that equation, how we got 4e over pi.
How we sorry, didn't get it. What we get? How we get?
4e over pi. 4e over pi.
I'm stupid.
The coefficient for the first of the Fourier equation.
How we get this complex AK forms?
Yeah.
Yeah. Very simple. First we have C and S. Scales for sine and cosine for, let's say, horizontal coordinate and vertical coordinate. If we we can use a Pythagoras theorem since they are orthogonal. The longest side of the triangle is a square root from the sum of squares, isn't it? It is. And
yes.
I will get cosine with the amplitude or angle by Pythagoras theorem and an angle as an arctangent, simple trigonometry. And then I use Euler's formula, I apply Euler's formula to this cosine. And I get complex form. I can replace cosine of something as a power j alpha to the something plus a power minus g alpha divided by half. Here I have without half, so I get the double cosine.
But then why 4e, Professor? The coefficient was 4e over pi. The Fourier equation.
Yeah, Fourier. And okay, and one more step back. What's the idea of Fourier law? Find scale factors or coefficients a1 or dc started from a0 to multiple to minimize distance in some space from our signal to its representation by the law. Is it?
Yes.
If we take as a base for coordinate system set of trigonometric function of sine and cosine at multiple frequencies, the best approximation, the closest distance, can be found as a 2 divided by period, integrating from, let's say, minus half of period to plus half of period, signal multiplied by cosine or sine of the frequency desired and in time. It's because Euclid norm in space is found as a let's say as a total sum of all distance. Between 2 points, Euclid norm is a square root of the coordinate difference square. When we have signal and some representing, Euclid norm should be taken at any minimal point between them. See, distance from object to object. I have one object and another object. I need to total distance somehow.
Yes, Professor, that's understood. But how do we write the final form? The 1 over 3, 1 over 5, or is that we just take it?
What do you mean final form?
The ST, when we convert it back, how do we write it and from where do we get those numbers?
Wait.
There was a 1 over 3, 1 over 5, and then those are the coefficients.
Yeah.
And cos is okay.
Yeah. Wait 1 second. We have we found what A0, A2, and A4 and A6 are zeros. Is it?
Yeah.
Now, what we get for A1? 4E divided by P. Yes?
No, 2E.
4. And 1 plus 1.
Professor, AK is equal to 2E over I pi.
A first will be 2E divided by JKP, and cosine of 0 is 1. Cosine of 0 is 1, so we get 1 plus 1. Cosine of P, minus 1. We need cosine of P. My camera will stop.
Yeah, 4 pi. Yeah.
2.
4E over pi.
Yeah.
Okay. So that is the first coefficient. Then the second one?
The second will be 0. The third one will be 1/3. The fourth one will be 0. The fifth one will be 1/5 of the 4E divided by pi. One second, I'll write the end form. So our signal can be replaced 4E divided by sine omega t plus 1/3 sine 3 omega t plus 1/5 sine omega t, and so on, where omega is nothing.
No, Professor, we were writing in cos, not sine.
If we shift cosine by 90 degrees, what we will get?
Yeah, then it will be sine.
Then we will sine.
Yes.
In more aesthetic form.
Yeah.
It will be 4E divided by P, sum that gives 1 to, let's say, infinity, 2k minus 1 divided by, multiplied by sine, minus 1 omega t. This form is one bit more aesthetic. One, 1/3, 1/5, 1/7, 1/9, 1/11, and so on. but I need to prove, isn't it? I can tell everything, but proof is needed. One moment, I need a short break. Camera stops now. 1 minute, and we'll see it live. Be right back. Okay. One minute.
Professor, maybe we can continue at 12:30 according to schedule?
No, we can do it right now. if you want. I'll be ready in a second.
Maybe a break would be nice, Professor. The lot to take it.
No problem. Actually, I'm ready, but if you need, why not? I'll be ready in a minute. So, we need a break.
Yeah, that would be nice, Professor.
Okay, so when we start? 12:30?
Schedule says 12:30, but
12:30.
we could start before that if you want.
Okay, we can do it. Then, maybe I'll start another stream to save a space on YouTube discs. It's okay?
Yeah, you can do that. Yeah, sure, Professor. Yeah.
Okay, so I'll